Hello everyone, myself Divya. Today I want to discuss about the mathematical model of a control system. So, we will discuss the mathematical modeling of a control system. So, to discuss this one, we have to know basically the control systems are how many types to determine the mathematical model. So, here I am explaining the control systems are classified as two types to determine this mathematical model. That means those are classified into mechanical systems and electrical systems. First one is mechanical and second one is electrical. So again in this mechanical system, the control systems are again classified into two types. Those are translational systems. The first one is translational system and the second one is rotational system. So basically to determine the mathematical modeling of a control system, the control systems are classified into two types. Those are mechanical and electrical. In that mechanical, again the systems are classified into two types. Those are translational and rotational. So here to determine the mathematical modeling, basically we have to determine the transfer function. So now it comes, what is meant by transfer function? So a transfer function is nothing but, here I am writing the formula. Laplace transform of C of t divided by Laplace transform of R of t. Already you know what is meant by C of t and what is meant by R of t. C of t is nothing but the control variable. That means the output of a control system. And R of t is nothing but the reference input signal which you are giving to a control system. So here what it indicates, from this equation, we can derive the transfer function. We can define the transfer function as the Laplace transform of output signal to the Laplace transform of input signal ratio is nothing but the transfer function. That means to determine the mathematical modeling, we have to require the transfer function. The transfer function is defined as the ratio of output response to the ratio of input signal. So here I am explaining the transfer function of a impulse response. That means impulse signal. What is the impulse signal? We can represent the impulse signal like this, right? At t is equal to 0 only, the value is 1. At all the remaining values, that means t equal to 1, 2, 3 and minus 1, minus 2, minus 3, the values are zeros. That means del of t is equal to 1 at t equal to 0 and del of t is equal to 0 if t not equal to 0. Now I am determining the transfer function of this impulse response. How we can determine Laplace transform of del of t is equal to integral of 0 to infinity into del of t into e power minus st dt. So here at integral of 0 to infinity del of t into e power minus st dt. So at t equal to 0 we know the value is 1. At t not equal to 0 the value is 0. So the final answer is 1 itself. So here we can place it as del of s is equal to 1. It means this is the input signal which you are giving to the control system. If a control system is like this, this is the input signal and this is the output. So here you can represent the input with R of t and output with C of t. I have to determine the transfer function. So what is the formula for transfer function? That is Laplace transform of output by Laplace transform of input. So that C of s by R of s. Is it right? If I am giving the impulse signal as the input to the control system, then what is the value of R of s here? That should be equal to del of s. So the value must be equal to 1. So it implies transfer function is equal to C of s by 1. So it means the transfer function which is represented by T of s that should be equal to C of S. So what it indicates? For a impulse response, if we are giving any impulse response to the control system, then the output must be equal to, the output control variable must be equal to the transfer function, right? So finally, T of S is equal to C of S, and later we will see what are the advantages and disadvantages of the transfer function. Coming to the advantages of the transfer function, by using this transfer function, we can obtain the mathematical model of every component in that particular control system. If for example I am using so many elements in a control system, then I can able to obtain the mathematical modeling of each element. That means the first advantage is I can able to obtain the mathematical modeling of every element in the control system. And the second one is I can obtain the stability of that particular control system. Stability of the control system. And the next one is I can able to obtain the poles, zeros and characteristic equation of the particular control system. Characteristic equation of the control system. And coming to the next advantage, from here, from this equation we can say that if we know the transfer function and output response of a control system, then we can able to determine the input signal. Otherwise, if we know the input response, that means R of S, and also if you know the transfer function, you can able to obtain the output signal, that means C of S. So these are the advantages of the transfer function. Then coming to the disadvantages. So here, coming to the disadvantages, the transfer function can be obtained for only linear time invariant systems. That means LTI. The transfer function can be obtained only for the linear time invariant systems. This cannot be obtained for the linear time invariant systems. And by using this transfer function, we are not able to determine the physical structure of the control system. For example, if in a system there exists one spring and one balanced dashboard, so what are the elements existing in that control system? We are not determining by using this transfer function. That may be a disadvantage, right? So this is about transfer function advantages and disadvantages. Now we will see the first system, that is mechanical translational system. So what are the elements present in a mechanical translational system and how we can obtain the equation for that particular elements. So the first one is mechanical translational systems. So here you have to remember basically there exist three elements in the mechanical translational systems. The first one is a mass element, and the second one is a dashpot or a damper element, and the third one is a spring. What are the three elements? First one is a mass element, second one is dashpot or damper, and the third one is spring. So for this mass element, there exists zero friction and zero elasticity. You have to take a mass element like that mass element should have zero friction and zero elasticity. Okay? And coming to the dashpot, for this you have to consider a dashpot having zero elasticity and zero mass. And coming to the spring, you have to consider zero mass and zero friction. Zero mass and zero friction. Now we will see in detail about these elements. So what is the first one? Mass element, right? How you can draw a mass element? That one I will show you. The first one is mass element, right? So here I am considering the mass element like this. I have to represent like M. M represents the mass of the element. So here this one represents the force which is exerting on the mass element. And here I am representing X. X means if I am applying some force F on the mass element, X is the displacement done by the mass element. Now, what is the relation between force and mass? F is equal to mv, right? That means mass into acceleration. What is meant by acceleration? The change in velocity with respect to time. That means can I write like this? A is equal to dv by dt. That means the change in velocity with respect to time, which is nothing but acceleration. So I can write as, I know already v is equal to dx by dt. Why? Because velocity is nothing but the change in displacement with respect to time. So v is equal to dx by dt. So from these two equations, I can write as f is equal to m into d by dt of v. That means d by dt of, what is the value of v here? Dx by dt. So dx by dt. So finally, I can obtain the equation f is equal to m into t square x by dt square. Is it right? This is the force which is applied on the mass element. So I can represent this one as Fm is equal to m into t square x by dt square. Okay. So here Fm is the force exerting on the mass element and m is the mass and x is the displacement done by the mass element. So this is the force exerted on the mass element. This mass element should have zero friction and zero elasticity. Zero elasticity. So this is about the mass element. Next we will see about dashpot or damper. The second one is dashpot or damper. So here we have to draw the dashpot like this one, like a piston. So here I am indicating B and this is X. X is nothing but same the displacement done by the dashpot and D is the dashpot coefficient. Dashpot coefficient. So here the force exerted on the dashpot can be represented as FB with a small letter. F suffix is small b. FB is equal to B into X. That means B into, not X, B into V, which is equal to B into dx by dt. So FB is equal to B into dx by dt. Here FB indicates the force which is acting on the dashpot and X indicates the displacement of the dashpot and B indicates the dashpot coefficient. So here for this dashpot you have to consider zero elasticity and zero mass. Okay. So this is about dashpot. And next coming to third element, which is nothing but spring. So here I am considering the spring. I am taking the spring like this and having a spring constant K, and this is the displacement done by the spring if I am applying a force Fk. Okay, a force Fk. Fk is nothing but K into X. So this is the equation for the spring. So now we will do a problem for the mechanical translational system to obtain a transfer function. So here I am writing the question. Obtain the transfer function for the mechanical translation system which is drawn below. You have to obtain the transfer function for y2 of s by f2 of f of s. Okay, this is your question. Now I am drawing the diagram. See here. So this is the base. From this I am considering a spring K1 and this is a dashpot. These two are connected to the mass element M1. This is the mass element M1 and this dashpot is indicated by D and this is the displacement Y1. This is the force F of T. That means if you examine force F of T, this is the Y1 displacement done. And here there is another spring which is named with K2 and it is connected to the mass element M2. Okay, so here the displacement is Y2. So here you have to determine the transfer function Y2 of S by F of S. How you can determine? First of all, you have to identify how many mass elements in that given particular mechanical translational system. So here how many mass elements are there? Two number of mass elements were there. So the number of modes is equal to number of mass elements, that equal to 2. So initially I am considering the first mass element M1. So here I am drawing the free body diagram separately. So this is M1. On M1 what are the forces acting here? So here F of T is the exerting force by a displacement Y1. And what are the forces acting on M1? The force due to the spring K1 and the force due to the dashpot B and the force due to the spring K2 and the self force M1. So here I am drawing Fk1 which is acting on M1 and Fb which is acting on M1 and the self force Fm1 and other force Fk2. And you should not write Fm2. Why? Because it is not directly added to the M1. Right? So these are the forces. So according to Newton's second law, you can write the equation F of T is equal to Fk1 plus Fb plus Fm1 plus Fk2. Is it right? So this is your first equation. So here I can obtain the individual equation for Fk1, Fb, Fm1 and Fk2. And I will obtain those equations and I will substitute in this equation. So here I am writing Fk1 is nothing but normal formula for Fk is K into X, right? So here K1 into what is the displacement done by this spring? Y1. Is it right? This is Y1. So here Y1 of T because it is changing with respect to time. And coming to the next force, Fb. Fb is equal to, in general, B into dx by dt. But here it is B into dy 1 by dt. And the next one is Fm1. So Fm1 formula is m into d square y1 by dt square. Is it right? And the next one is Fk2. Fk2 is nothing but K2 is here, right? So you have to consider both the displacement y2 and y1. You are considering m1, so you have to take the reference as y1. So here you have to take K2 into y2 of t minus y1 of t. So this is the equation for Fk2. Now you have to substitute all these equations in this equation, right? So here I am writing the equation. So what is the final equation here? F of t is equal to, what is the first one? Fk1. So Fk1 is equal to K1 into y1 of t plus b into dy1 of dy1 by dt plus what is the next term? fm1. fm1 is nothing but m d square y1 by dt square, and what is the next term? fk2. fk2 is nothing but k2 into y2 of t minus y1 of t, right? So this one is y1 minus y2 because you have to take this one as the reference. So this is y1 and this is y2. So here this one is y1 and this one is y2. Okay, so this is the first equation. From this you have to determine the Laplace transform for this equation. So here f of t is equal to k1 into, directly I am applying Laplace transform here. So f of s is equal to k1 into y1 of s plus b into s into y1 of s plus s square m1 y1 of s plus k2 into y1 of s minus y2 of s. So this is the final equation which is obtained by doing the Laplace transform for the obtained equation. And next you have to obtain the free body diagram for the mass element m2. So here I am considering the mass element m2. So what are the forces acting on the mass element m2 here? The forces which is acting by the k2 and the self force due to the m2. So here this is fk2 and this is fm2. So what is the final equation obtained by using Newton's second law? fm2 plus fk2 is equal to 0. What is the individual equation for fm2? fm2 is nothing but m2 d square y2 of t divided by dt square plus fk2 is nothing but k2 into y2 of t minus y1 of t, which is equal to 0. And for this equation also you have to apply the Laplace transform and you have to determine the value of y2 of s and y1 of s. From that we can determine the final transfer function y2 of s by f of s.